Hi, good day. It's Mr. Mustafa here. In this video, we're going to solve the Mathematics Paper 1, November 2024. So let us get straight into question 1 and start solving. We see that question 1.1.1, we see that we have factors already, so we can just write down the answer is already factorized. So x is equal to 0, or the second bracket needs to be equal to 0, so x is equal to 3. So obviously if x is equal to 0, 0 times the bracket would just be 0, or if the value of x is 3, 3 minus 3 is 0, 0 times x will also be 0. Next question, 1.1.2, we see that we have 2x squared plus 1 equals 4x. It says correct to 2 decimal places. In order to solve this problem, we need to bring the 4x over, write it in standard form. So 2x squared minus 4x plus 1 is equal to 0. You need to use the quadratic formula from the formula sheet, which is given as x equals minus b plus minus the square root of b squared minus 4ac divided by 2a, right? Divided by 2a. You can see the value of a is 2, value of b is negative 4, and the value of c is equal to 1. So substituting all these values inside here, you're going to get negative 4 plus minus the square root of b squared, which is negative 4 all squared, minus 4ac. So what's the value of a? A is basically 2, and the value of c is 1, all over 2a. The value of a is 2 actually, so let's write it down. So what we have here is 4 plus minus, I'm trying to simplify this function so it'll be easier to type, that is 16, or you can just type this entire thing with a minus then with a plus, as is on the calculator. You should get the answer. So we had 4ac, so that is 16 minus 8, which is 8 all over 4. So I will type 4 minus square root of 8 over 4, and 4 plus the square root of 8 over 4. So I'm just popping my calculator back to the screen. So I hope you can see my calculator on the screen. As we see here, 4, the fraction button, let's put the fraction 4 minus the square root of 8 over 4. I'm getting an answer of 0.29. So x is equal to 0.29, or x is equal to, and the one with the plus will give me 1.71. Right, so I hope you guys are understanding. If you have this silver calculator, remember you can go mode 5.3 and solve it in the equation solver, which is 2 minus 4 and 1. Just want to see if we get the same answers. Yes, 2 plus root 2 and 2 minus root 2 over 2. Yes, so the answer is correct. Let's move on to the next problem. We have x squared minus 2x minus 3 is greater than 0. This is a quadratic inequality, so we will factor this out. X minus 3 into x plus 1 is greater than 0. You can draw a number line, or you can use a graph, right? So the factors are, the critical values are negative 1 and 3, and you can go plus minus plus, or you can draw a graph of a happy face. So this is positive, negative, positive. Take any value after 3, like the number 10, substitute it inside. Positive times positive is positive. Because these are linear factors, it will alternate. So we want the answer which is positive. So x is greater than 3 or less than minus 1. So what's the answer? X is greater than 3 or x is less than negative 1. Moving on to the next question, which is exponential equations. So what we're going to do is, we can see it's a special form of an exponential equation. which is in the form of a quadratic. So we will decompose first. It says 2 to the power x times 2 to the power x minus 2 to the power x times 2 squared minus 32 is equal to 0. You can say let 2 to the power x is equal to k. You can use a k substitution. Right, so we got k times k, which is k squared, minus 2 squared is 4, 4 times k is 4k, minus 32 is equal to 0. We can see that 8 times 4 works, so we have k minus 8, k plus 4 is equal to 0. Plus 4 minus 8 minus 4k, everything is good, so we have k is equal to 8. But what is k? That is 2 to the power x. What is 8? 2 to the power 3. Therefore, drop the base, equate the exponents, so x is equal to 3. Or k is equal to negative 4. So we will say 2 to the power x is equal to negative 4. We can't really solve this because 2 to the power x is always positive, knowing the graph of 2 to the power x, right? So we say no real solution here, since 2 to the power x is always positive. We can't get a negative value for 2 to the power x. Right, so your answer is x is equal to 3 only. It's just the value of x, which is 3. I hope you guys understood that. Nice question. Moving on to a Surds equation. We have square root of negative 2x plus 4 equals, let's take this x over, so we have square root of negative 2x plus 4 is equal to 2 plus x. Now, the square root of anything must always be positive, so we can get a restriction. We can say a restriction is x plus 2 has to be greater than or equal to 0, so x is greater than or equal to negative 2. So we can only choose answers for x which is greater than or equal to negative 2. We can't choose answers that does not satisfy this inequality. Right, so in order to solve this problem, we will square both sides and then we will proceed. Right, so let us square both sides. Squaring, you will get negative 2x plus 4 equals 2 plus x all squared. Right, so basically we are squaring both sides, right, and we're squaring here. Now squaring this side will give me negative 2x plus 4. Squaring 2 plus x all squared will give me 4, plus squaring a binomial x times 2, which is 4x plus x squared. Now writing everything in standard form, just bring everything to the right hand side instead of the left hand side, because we have a positive x squared there. So x squared, we have 4x plus 2x, which is 6x, and we have 4 and 4 cancelling out on both sides, so that's great. Simple to simplify, right? So we can factor out an x. We have x plus 6. So what's the answer? X is equal to 0 or x is equal to negative 6. Clearly x can't be equal to negative 6, so we say reject here. So the only answer that will work is x is equal to 0. You can check if negative 6 works. Let's take negative 6 and put it into the original function. Square root of negative 2 times negative 6, which is 12 plus 4. 16 square root of 16 is, square root of 16 is 4. 4 minus 6 is 10. Is 10 equal to 2? No, so reject. But if you substitute 0, you should get square root of 4, which is 2. 2 is equal to 2. Perfect. So x is equal to 0 only. Solve for x and y simultaneously. Next question. You can make y the subject of the formula, which is an easier case. So y is equal to 3 minus 2x. Take 3 minus 2x and substitute in the place of y. So we have 3 minus 2x all squared plus x times 3 minus 2x is equal to 2. Now squaring this binomial, you'll get 9 minus 12x, because minus 2x times 3 is minus 6x times 2 is minus 12x, plus 4x squared, right? So that is sorted out. Now we take the x inside the brackets here, open them up, plus 3x minus 2x squared, bring the 2 over, minus 2 is equal to 0, because it's one linear, one quadratic, right? So you will solve a quadratic equation. Now we have 4x squared minus 2x squared, which is 2x squared. Now let's look at all the like terms with the x. We have minus 12x plus 3x. So we have minus 9x, adding them up, and 9 minus 2 is 7, plus 7 is equal to 0. Now to factor this out, we have 2x and x, right? 2x times x is x squared. So the only factors that will work is, let's see, will 7 work? 7 goes here. It's just 7 and 1. X minus 2x squared minus 2. 2 minus 9 and 7. I just want to use the calculator and see if this here factorizes. Otherwise you can use the b squared minus 4ac. Mode 5 3. We have 2 minus 9 and 7. Okay, so it does work. 2x minus 7. So the 7 goes here. Right, and so yeah, factoring, you can only use the numbers 1 and 7. Okay, so 1 here and 7 there, so you get minus 2x minus 7x. So x is equal to 7 over 2, or x is equal to 1. If x is equal to 1, you will get 3 minus 2, which is y is equal to 1. And if x is equal to 7 over 2, so you'll get 3 minus 7, because the 2 and the 2 will cancel out. So 3 minus 7 is negative 4. 3 minus 2 times 7 over 2. Yes, so 3 minus 7 will give me negative 4. So these are the answers that work. Right, so it's these two, right, and these two. So x equals 7 over 2 and negative 4, or 1 and 1. These are the answers for x and y, x and y. These are the coordinates that will work. Moving on to question 1.3. Right, so we have consider the product. So what type of product is this? 1 plus 1 over 2, 1 plus 1/3, 1 plus 1 over 4, and it continues right up to infinity. So we have an infinite product. Okay, so each factor in the product is of the form, yes, it does make sense, for n is greater than or equal to. So if you are going to generalize this, n is greater than or equal to 2. So this product, we can rewrite it as 1 plus half can be written as 1 plus half is 3 over 2 dot. So remember the product, same thing. Trying to determine all the values of n. Determine all the values of n for which the product will be an integer value. Ooh, right, so 3 over 2 times 4 over 3. Difficult question in question 1, right? 4 over 3, 5 over 4. So what we have? 2, 3, 4, 3, 4, 5. And then obviously we'll have more terms here, dot dot dot. What will this give me? N plus 1 over n. So the term before this will be 4 and 4, so there'll be n there, and it will be 1 less than this. This will be n minus 1. N minus 1, n plus 1. So it seems like but remember, this is an infinite product, so remember, even beyond this it continues, dot dot dot. It doesn't stop there, but I just want to see what happens in this case. We can see the 3 and the 3 cancelling out, the 4 and the 4 cancelling out, 5s and the 5s will cancel out, the n and the n cancelling out, n minus 1 cancelling out with n minus 1 there, somewhere around there. So what we are left with is n plus 1 over 2. Right, so it's of this form, n plus 1 over 2 times, yes, this entire thing over here is is up to n terms. This is up to k number of terms. Yeah, so what we are getting is n plus 1 over 2, because it's an infinite product. Why did they put it as an infinite product? They should have ended it off with 1 plus 1 over n for n is greater than or equal to 2. Okay, so all this here simplifies to n plus 1 over 2. So this here needs to be an integer. So how can this here be an integer? If n plus 1 is even, in other words, n needs to be odd. So n is odd because, okay, in order for this to be an integer, n plus 1 is even. This implies n is odd. So if n is equal to 3, if n is equal to 3, 3 plus 1 divided by 2 will give me an integer. So if n is equal to 3, if n is equal to 5, n is equal to 7, n is equal to 9, and so on. So these are all the value, determine all the values of n for which the product will be an integer value. So these are all the possible values of n. I think this should be the way of solving it. If you have any other methods, don't forget to comment. Right? Thank you. Let's continue with this question number 2. The first 10 terms of an arithmetic series is 7. Right? So you know the Tn formula. Tn is equal to a plus n minus 1d. The first 10 term of an arithmetic series is 7. The first term of an arithmetic series is 7. Sorry, it's the first term, not the first 10 term. The first term of an arithmetic series is 7. You know the formula, a plus n minus 1d is in the formula sheet. So the first term they're talking about is a. The common difference of the series is 5, so they're talking about d. So you have a and d, and the series contains 20 terms, and you have n. Calculate the sum of the series. So you want to go and calculate the sum of the series. What's Sn? N over 2 into 2a plus n minus 1 d. So S20 is equal to 20 divided by 2 into 2 times a, 2 times 7, right, plus 20 minus 1 d, which is 5. Now let's substitute this. Let's try to calculate this. Simplify, so we have less to type in the calculator. So we got 14 plus 19 times 5, right? So I will just do this in the calculator. I will say 19 mode 1, 19 times 5 plus 14, that's giving me 109, and then times 10, so 1090. That's the sum of the first 20 terms. Remember, this is a formula, n over 2 into 2a plus n minus 1d. A is 7. Just check if we substituted everything correctly. The common difference of this series is 5, and the series contains 20 terms. Yeah, so talking about a series, which means the sum of the terms. That's what we need to calculate. Right, perfect. Let's continue with the next question. The original arithmetic series is extended to 75 terms. Right, so what was the series? The original series, which is 7 plus, is extended to 75 terms. It means there are 75 terms in total. Right, 7 plus 12 plus 17 plus dot dot dot, and we got n is equal to 75 terms. Right, originally we had 20 terms, now we have 75 terms. The sum of these 75 terms is 14,400. Right, so remember we got plus term 75 at the end. We can find that out, but no need. Using sigma notation, write down an equation for the sum of the terms added to the original series. Using sigma notation, write down an equation for the sum of the terms. Using sigma notation, write down an equation for the sum of the terms added to the original series. So we need to use sigma notation. Right, so first let's go and calculate what is the Tn formula here. So Tn is equal to a plus n minus 1d. A is 7 plus n minus 1d, which is 5. So you got 5n plus 2, because minus 5 plus 7, 5n plus 2, right? Sigma sum k equals 1 to 20 of 5n plus 2. That was the original sum, plus I'm adding another k equals 21 to 75. I'm adding another 50 terms of 5n plus 2, right? And the sum is equal to 14,400. Is this what they are asking us for? I just want to see if this sum total is 1090 first, right? So let's see. Shift. Remember, the special calculators have all this. So alpha x plus 2, and from 1 to 20. I just want to see if this original sum was, yes, it was 1090. So the sum of all the 20 terms plus 21 to 75 of 5n plus 2 will give me 14,400. Using sigma notation, write down an equation for the sum of the terms added to the original series. These are the sum of the terms added to the original series. Write down an equation for the sum of the terms added to the original series. So I'm just going to write sum of terms added to the original series. Sum of terms added to the original series is equal to yes, what is it equal to? Sigma k equals 21 to 75 of 5n plus 2. But we already know that k equals 1 to 20 is 1090. So I'm sure we can simplify this equation. So you can write k equals 21 to 75 of 5n plus 2 is equal to 14,400 minus 1090. So we should get this equation, 14,400 minus 1090, 13,310. Right, so this is basically equal to 13. This is a simpler equation, because remember, we solved this part in part 1. This is already 1090. So I took it over and I just subtracted it. Sum of the terms added to the origin series. Yeah, this should be fine. Now remember, there are 50 terms here. 75 minus, sorry, not 50 terms. There will be 55 terms here, because 75 minus 21 plus 1. So 75 minus 20. Yes, there should be 55 terms. Right, let's continue. If you have other methods, don't forget to comment in the comment section below. The sequence of the first difference, so now we're moving on to a quadratic pattern. The sequence of the first difference of a quadratic pattern is 135. If term 99 of this quadratic pattern is 9632. Calculate the value of term 98. So we have the sequence of the first difference of a quadratic pattern. Now remember, we don't want to get confused here, right? So let's see. 135. So you know you have a quadratic pattern, right? I'm just trying to draw these square boxes, and right, so and build the theory behind this, right? So let's take this. Right, so I'm going to put 4 terms here, right? Next one is here. Right, and then obviously the difference between these two will give me a second difference. Right, so we know it's a quadratic pattern, so second difference will be constants, and we usually do a thing like this, right? So the difference, so we have 1, 3, 5 right here. If term 99 of this quadratic pattern, so term 99, what they're doing here, this is term 4, right? Term 4 minus term 3. Term 99 is somewhere around here, okay? Should have put 2 more boxes here, right? So to depict term 99, alright, and term 98. So let's delete this. So remember these dots going out, this is term 99, 98, and this is term 99. We know the value of term 99 is 9632. Calculate the value of term 98. So we want to calculate the value of this. So obviously a certain number of terms needs to be added, right? We got 135. We can get a pattern for this, right? So it looks simple, right? So what we can say is the pattern for this. So we can say the first difference pattern is Tn is equal to, we are adding 2 each time, so 2n minus 1. Because it's a pattern for odd numbers, 2n minus 1, 2 times 1 minus 1, 2 times 2 minus 1, 2 times 3 minus 1, 2n minus 1. So if I work out term 3, here, I'm getting 5. And 5 is the difference between quadratic pattern number 4 and quadratic pattern number 3. Right. So let's see what this here can depict. So this formula here can tell us similarly that if I try to do term 98, then it's going to be quadratic pattern 99 minus quadratic pattern 98. Right. So this is what we're looking at, and term 98 we can find from this formula here, 2 times 98 minus 1. 2 times 98 minus 1. What is 2 times 98 minus 1? 195. Now it's easy to find quadratic pattern number term 98. So quadratic 98 will be, quadratic 99 is already 9632, right? And we're going to subtract 195 to get the answer. So 9632 minus 195 will give me the answer 9437. So 9437 is the answer. Calculate the value of term 98. Therefore term 98, you should write term 98 of the quadratic pattern is 9437. I hope you guys understood that. Nice question. if it is further given that the third term of the quadratic pattern is 32, right, so what we know is that the third term is 32. Determine the general term of this quadratic pattern. Let's find the general term of the quadratic pattern. Now remember, the common difference is 2 here, and it's constant 2. So this is d2, d1, and the third term is third term of the pattern is 32. So obviously if the third term of the pattern is 32, then we can get this term here, which is 29. 29 plus 3 is 32, and then minus we can recover the first term, which is 28. 29. So we added 1, we added 3, we added 5, and so on. Alright, so we can just work with this now to find the quadratic pattern. So using the formulas, we got 2a is equal to d2, the three formulas. 2a is equal to d2, 2a is equal to 2, therefore a is equal to 1. Now 3a plus b is equal to d1, right? d1 is 1. 3 times a is 3 plus b, so b is equal to -2. And the last one, a plus b plus c is equal to term 1, and term 1 is, I think, 28. And we know a plus b, -1 plus c, so c is equal to 29. So tn is equal to n squared minus 2n plus 29. Now we need to check this. Let's substitute term 3, because we had term 3 is 32. So we will say 3 squared minus 2 times 3 plus 29. Right, perfect, we're getting 32. Let's try the other one, 99. 99, 2 times 99. Right, so we're getting 9632. Was it 9632? Yes. And if you put 98, you should get, let's put term 98. What's the answer? 9437. Yes, 9437. Perfect. So it's all good. Let's move on. Hope you guys understood that. Simple. Right, a circle with the radius 6 centimeters is drawn. Right, a second smaller circle is drawn through the center of the first circle. So this was radius 6. Okay, a second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third smaller circle is drawn through the center of the second circle. So again, so remember the entire distance was 3, so now we got 3 here because the whole thing from the top to the center is 6, radius 6, but is drawn from the center of this circle. So obviously that is 3, that will become 1.5. The radius of this will now become 1,5, because this entire diameter here is 3. So the process of drawing circles continues and forms a geometric pattern. Write down the radius of the third circle. A second smaller circle is drawn through the center of the first circle. So guys, this is circle 1, right? This is second circle. So radius of the third circle is 1,5, right? As we see here, it was 6, the whole thing is 6, then that's 3, that's also 3, so the radius of this will be, yeah, 1,5. A third smaller circle, write down the radius of the third circle. Right, so we got 6, 3, we're basically dividing it by 2 each time, starting from 6, radius 6. So that's your, yeah, so basically that's kind of like your pattern. Right, let's move on to the next question. We got our answer here. Radius is 1,5. Calculate the sum of the areas of the first 10 circles. Whoa. Let's see. Sum of the areas of the first 10 circles. So circle 1, we know the pattern, the radius, the R pattern is 6, 3, 3 over 2, 3/4, and so on. Okay, basically we're just dividing everything by 2. So the area is going to be, area of the first circle is pi r squared, we're squaring this, plus pi r squared here. R1 squared plus pi R2 squared. Okay, so we are basically squaring each one, and then you can remember this is R3 plus dot 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 plus pi R10 squared. Calculate the sum of the areas. S10 is equal to pi into R1 squared plus R2 squared plus R3 squared plus dot 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 plus R10 squared. Calculate the sum of the areas of the first 10 circles. We are basically doing this, sum of the areas of the first 10 circles. So we need to square these things here, the radius. But does the square of the radius form a geometric pattern? That's what we need to check. So we got 6 squared. Now the pattern becomes, what's our R squared pattern? It becomes 6 squared, 3 squared, 3 over 2 squared, 3/4 squared, and so on. So what's a common ratio? The common ratio, do we get a common ratio here? Common ratio is 3 squared divided by 6 squared, which is basically half squared. Yeah, that's basically 9 over 36, so is half squared. In other words, we are getting quarter. Let's try this out. The next common ratio, 3 over 2 divided by 3 squared, or let's try 3/4 over 3 over 2. 3/4 over 3 over 2. 3/4 divided by 3 over 2. Yeah, so this here forms a geometric pattern. Geometric, right? Common ratio, first term, A is equal to so common ratio is quarter. A is the first term, which is 36, so we can just calculate S10. So S10 is equal, SN formula, Sn is A 1 minus R to the power n divided by 1 minus R, because the series converges, right? It converges. Now remember to add the pi multiplied by pi. So what we're going to do now is calculate S10. Don't forget to multiply by pi the whole answer. A is 36, 1 minus, we have quarter to the power 10, okay, divided by 1 minus quarter, and let's see what this answer gives us. So fraction, we got 36 into 1 minus 0.25 to the power 10, because there are 10 terms, divided by 0.75, because 1 minus quarter is 0.75, right? We're getting 47 times shift pi. So I'm getting an answer of 150,796, 150,80, 796, yeah, comma 80, 80 what? Centimeters, what was it? 6 centimeters, so centimeters squared. That's what they wanted. Calculate the sum of the areas of the first 10 circles. The sum of the areas of the first 10 circles. Yeah, so that should be the answer. Or you can write it as, can we write it as 48 pi divided by shift pi? What was my answer? It was 48 pi. Okay. Which circle has a diameter of 3 over 128 centimeters? Which circle? Which circle has a diameter of 3 over 128? Diameter of 3 over 128 implies a radius is equal to diameter divided by 2. So 3 over 128 times half. So 3 over, what's 128 divided by 2? 128 divided by 2, 64. 3 over 64. So we basically looking for the Tn formula for this R. So Tn is equal to a r to the power n minus 1. This implies Tn is equal to a was 6, using the r, the radius, r is 6, the common ratio was half, to the power n minus 1 is equal to 3 over 64. Right, so 3 over 64. Solving this problem, how can we solve this? We take 3 over 64 divided by 6. Right, so we're taking 3 over 64 and we're going to divide it by 6. So we get 1 over 128. So half to the power n minus 1. But we know that 1 over 128 is 1 over 2 half to the power 7. So therefore n is equal to 8. So the 8th circle, which circle? 8th circle has diameter 3 over 128. So it's the 8th circle. Let's see if this answer is correct. Let's substitute 6 times. We need to double check the answer. 6 into 1 over 2 to the power 8 minus 1, which is 7. Yeah, we're getting 3 over 64. And if you multiply the radius by 2, we're getting 3 over 64. Made a mistake. Multiply by 2 should be 256, not 64. That's why this is not working. Alright, so 256, mistake, right? So 256, not the 8th circle then. That's going to change. That's 3 over 6 times half to the power n minus 1 is equal to 3 over 256. That's 3 over 256, because we're doubling 128 times 2. Yes, half, 3 over 256 divided by 6. 3 over 256. I'm going to divide it by 6. So you're going to get 512. So you get half to the power 9. Half to the power 9. Half to the power 9. So n is equal to 10. So 10th circle has a diameter of 3 over 128. Let's check if this answer is true. So you're going to take 6 into 1 over 2 to the power 9. You get 3 over 256, and multiply it by 2, radius times 2, you get a diameter 3 over 128. So this is correct. The 10th circle, not the 8th circle. That's why it's very important to check your answer, guys. Right, so I hope you did it the correct way like this, not the previous way. Made a mistake here. Instead of writing, yeah, I went and divided this. All right, so that's why we have to check the answer when you're solving. Right, so far the paper is good, simple. Right, we have f of x, which is a to the power x minus 1. We have an exponential equation shifted 1 unit down, and the point B is 2 and minus 5 over 9 is a point on f. Calculate the value of a. In order to calculate the value of a, we're just going to substitute this point inside here and solve. So remember, y 4.1, y is equal to a to the power x minus 1 at b. Remember, the coordinate of b is 2 and minus 5 over 9, so that's x, that's y. So minus 5 over 9 is equal to a squared minus 1. Right, so we're going to add 1 on this side. You get 4 over 9, which is a squared. Now a square root, so plus minus 2/3. This implies a is equal to 2/3 only. Choosing positive, a is positive. I'm choosing values of a which is positive, which is given. So we got the answer, which is a, which is 2/3. Okay, let's see if we did this correctly. Minus 5 over 9 plus 9 over 9, which is 4 over 9. You can just add it up onto the calculator and take square root both sides. So we got the value of a. Write down the range of f. Now remember, this exponential graph is above the asymptote line. Remember, that's the asymptote line, minus 1. So remember, the exponential graph looks something like that, right? And the asymptote line is here, y is equal to -1. It doesn't touch the asymptote, so it's above. So y is greater than -1. That's your range. Sketch the graph of f. Clearly show the intercepts with the axes and the asymptotes. So obviously we need to find x-intercepts, y-intercept, and then sketch the graph. So x-intercept, we have the function f of x is equal to 2/3 to the power x minus 1. Right, so x-intercept is making y 0. So you got 2 over 3 to the power x minus 1 is equal to 0. Take the 1 over. 2/3 to the power x is equal to 1. Now how can you write 1? You can write that as 2/3 to the power 0. Anything to the power 0 is 1. So x is equal to 0. So this graph passes through the point 0. And what's the y-intercept? The y-intercept is making x 0. So f of x, y-intercept is making x 0. So we have 2/3 to the power 0 minus 1, which is 2/3, which is also 0. And we have a point which is 2 and minus 5 over 9, point B. 2 and minus 5 over 9. So we get 0, 0, and 2 and minus 5 over 9. So we can connect those 2 points and see what the graph looks like. So let's draw the graph. I know the asymptote is at -1. So I'm going to break up this line, -1 asymptote. So y is equal to -1, 0, input 1, 2. And we know the point is 2 and -5 over 9, somewhere around here, right? And the next point is 0. So if you connect these two dots, you know that this graph is downward sloping, right? So I have the function f, I have the point B, I got 1, I've got 2, right? Point B is right here. That's the x-axis, that's my y-axis, and sketch a graph of f. Clearly show the intercepts with the axes and asymptotes, if any. So there is a horizontal asymptote at y equals -1. Right, so that's my graph. Perfect. Let's move on. If it is further given that C is a point on f at y is equal to 19/8, so the point C is somewhere around here. Okay, 19/8 is like 2 and something. Right, so it's somewhere around here. So we can get the x value here. So because that's 19/8. Determine the coordinates of C prime, the image of C, when C is reflected about the line y equals to x. So first we need this coordinate C. Right, so first we need this coordinate. How do you get 19/8? We're going to put 19/8 in the place of x here. Right, so 2 to the power 2/3 to the power x minus 1 is equal to 19/8. That's what we need to do, because the y value is 19/8. Okay, right, so remember the y value is equal to 19/8. Now we're going to add 1, so we will get 27/8, which is 2/3 to the power x. Now 27/8 is 3/2 cubed, which is equal to, flip this, you get 2/3 to the power -3. Correct, rules of exponents. So now we can drop the bases, or you can just use logs, right? Drop the bases here, and we got x is equal to -3. We know the value of x will be -3, because you can also use trial and error and figure out the value of x is -3. How? You can say 2, we can put it in brackets, 2/3, okay, to the power -3 minus 1, and see what we're getting. We're getting 19/8. So the value of, so what's the coordinates of C? Coordinates of C is -3 and 19/8. So the coordinates of C prime, C1, will be, it's a reflection about the line y equals to x. So if you reflect this C about the line y equals to x, we just need to switch the coordinates, right? So it's 19/8 and -3. That's what the coordinate will be, because you're reflecting that point directly across. It's going to be -3 on the y value, and 3 and 2 and something, 2 and 3/8. Okay, I hope you guys understood that. Let's move on to the next problem, which is question number 5. So far the paper is good, it's simple. Just in question 1, that difficult question there, and I think also this one here students will mess up. Right, so far the questions are good. Even this one here they might mess up. Anyways, not very difficult. Only that question number, in question 1 we had that was a bit difficult, this one here. Let's move on to question on the rational function, which is the hyperbola, right? And let's see, the hyperbola is okay, basic hyperbola a over x plus b plus q, having the domain -infinity to 1. So the line domain, so x values, so 1 is the asymptote here, because you can clearly see it's not included. Got 1 as a vertical asymptote, so obviously the value of p will be -1. And we got q, the graph of f cuts the y-axis as 0, 1. Right? A line of symmetry of f is given by g of x, so that's the positive axis of symmetry. Obviously it goes through the horizontal and vertical asymptote. Alright, so let's see. Write down the value of p. The value of p will be 1 or -1. It should be -1, right? So p is equal to -1, because if I put -1 in here, I need to get opposite signs for the vertical asymptote, so it will be 1. Yes. Determine the equation of the horizontal asymptote of P. Equation of the horizontal asymptote of F. How are we going to find the equation of the horizontal asymptote? That's 5.2. Yes, should be an easy way of finding. How can we find it? 5.2. In order to find this, yes, the axis of symmetry is given, right? It's x minus 3. But now how did we get the positive axis of symmetry? You went in this pattern here, right? So you said y is equal to x plus p plus q. So y is equal to, we know x plus p, x minus 1, p is minus 1, plus q. Now that's equal to already x minus 3. Remember, this is a formula to find the axis of symmetry, the positive one. Positive axis of symmetry, find it like this. Right, so x minus 1 plus q, but we know that that's already equal to x minus 3. So what we know is that x and x can cancel out, right? And q is now equal to minus 3 plus 1, which is minus 2. So we got the value of q, which is minus 2. But what did we want? We wanted the horizontal asymptote. The horizontal asymptote is y, because now the value of q is negative 2. So y is equal to negative 2. Therefore, horizontal asymptote equation, y is equal to negative 2. Calculate the value of a. How are we going to calculate the value of a? We can see the point 0, 1 lies here, right? So to find the value of a, we can just substitute 5.3. We got y is equal to a over x minus 1 minus 2 at 0, 1. Now substituting the point 0, 1, 1 is equal to a over negative 1 minus 2. So we can just take this a over, becomes positive a, bring the 1 over, the value of a is negative 3. That's what we expected the value of a to be, which is negative. So the value of a is negative 3. So now we got a, p and q. Problem sorted. Right, so moving on to the next question. For which values of x is f of x greater than equal to 0? Right? So when can we find f of x greater than equal to 0? And let's copy this and solve it here. F of x is positive when is f of x positive? In other words, when is the graph of f above the x-axis? The graph is positive here, so we need to find the x-intercept. So what's the x-intercept? Nice question regarding x-intercept. So we got y is equal to negative 3 over x minus 1 minus 2. That's the equation. A vertical asymptote is 1, horizontal asymptote is negative 2, the value of a is negative 3. We want to solve the x-intercept, make y 0, so negative 3 over x minus 1, okay, making y 0, right? So we got 0 equals negative 3 over x minus 1 minus 2. Take this whole thing over. We got 3 over x minus 1 is equal to negative 2. Right, we can cross multiply and solve this equation. So we got minus 2x plus 2 equals 3, minus 2x equals negative 1, positive 1, 3 minus 2, so x is equal to negative half. So we know the x-intercept is negative half. So when is the graph positive? When the value of x is between minus half and 1. Be careful, you can't say just greater than minus half, then it can be 1 as well. So it's between minus half and 1. So the answer is between minus half and 1, right? So what's the answer for this problem? 5.4, between minus half and 1. So minus half, x is greater than or equal to minus half, but less than 1. Make sure that this here, the inequalities are correct as well. right? So first you solve for the x-intercept and then you decide, right? When it is positive, when it is greater than equal to minus half but less than 1. We can't include 1 because that's a vertical asymptote. Next question, quite interesting. Let me just copy the next question down, because they usually have like modified questions towards the end. The graph f undergoes a transformation to h. So f undergoes a transformation. We know what the graph of f looks like. This is the graph of f. The domain and range of h are the same as that of f. So in other words, the horizontal and vertical asymptote does not change, right? So no change in horizontal and vertical asymptotes. That's what we know from this. H prime x, the derivative of h is negative on its domain. The derivative of x is negative on its domain. H prime x is negative on its domain. At the moment, the graph is all positive. Describe a possible transformation of f could have gone to result in h. So we know the graph of f. Graph f undergoes a transformation to h. F is y equals negative 3 over x minus 1 minus 2. We know the graph looks like this. Okay, you know the graph is here and the graph is there. So we know this is positive because it's an increasing function, alright? The original f graph is always increasing. So f prime x is greater than 0. That's what we know. But now these asymptotes are remaining the same. Describe a possible transformation that f could have undergone to result in h. So in other words, this here can be negative. Can we reflect on the, if you reflect on the x-axis, can it be a reflection on the x-axis? Or y is equal to x? H prime x, the derivative of h is negative on its domain. In other words, this graph is going in the first and third quadrants. So now how does the graph goes away here and there? The graph goes here and there. How? Reflection about the line y is equal to x. If you reflect about the line y is equal to x, then we're going to get x is equal to y is equal to x. S is equal to minus 3 over x minus 1 minus 2, y minus 1. How can I solve this? Bring the 2 over x plus 2. What transformation can this take on? Reflection on the x-axis? Reflection, no, not reflection on the x-axis. How can I get the same graph? Y is equal to 3 over x minus 1 minus 2. I don't want to change the domain and the range. Domain and the range remains the same. That's what they're saying. So we're not changing the asymptotes, horizontal and vertical asymptotes, but the graphs becoming negative. That's the graph. That's the graph. The graph is becoming negative like this. Sorry, not graph becoming negative, the derivatives are becoming negative. So how do we go from, yeah, we just need to write down the transformation from f to h. F to h, what transformation can it be? What if I say that is 3 over x minus 1 minus 2? Then I'm getting, am I getting an x-intercept? Yes, you will get an x-intercept, which is half. No, x-intercept will get, that's 1, that's minus 2. If I make x 0, I'll get minus 5 here. The original graph was 1 0, becoming minus 5 0. Distance 3, distance 3. F to h, okay. And what about the x-intercept? If I make y 0, 0 equals 3 over x minus 1 minus 2. Take the 2 over, we're getting 2 over 1, which is 3 over x minus 1. I just want to solve this. It's a little bit challenging, right? X minus 1. Now, cross multiply, we're getting 2x minus 2 equals 3, getting 5 over 2. X equals 5 over 2, which is 2.5. So I'm kind of reflecting this graph. This is 5 over 2, and that was actually half. It's a reflection on the asymptote y is equal to negative 2. I'm kind of reflecting this graph on the asymptote. Reflection on the asymptote, because this bottom graph, it was like this, now it shifts up. Alright, and this bottom graph, yeah, reflection on the horizontal asymptote, which is y is equal to negative 2. Right, so that's the answer that I can come up with, so that we don't change the domain and the range, but we change the a value from negative to positive. Yes, and that should do it. So if I'm changing this bottom graph goes there, that top graph goes down. Yes, if you fold along that, yeah. So quite challenging, that one. Right, let's move on to the next question. Question 6. In the diagram below, the graphs of f of x, the entire equation is given, right, of the parabola, and G, a straight line, are drawn. C is 3 and 8, is the point of intersection of f and G. EH is parallel. EH, so we have EH is drawn parallel to the y-axis, with E a point on F and H a point on G, right? Calculate the coordinates of B, the turning points of F. 6.1. X is equal to minus B over 2A. Minus B will be minus 4 over 2 times minus 1, which is going to give me 2, right? and f of 2 is going to give me minus 4. 4 times 2 is 8, plus 5, right? So we're getting 4 plus 5, which is 9. So we're getting 2 and 9, right? So the coordinates of B is 2 and 9. I just use grade 11 knowledge to find this. Right, show that the equation of the line through A and C is given by 2x plus 2. Let's find the coordinates of A. Simple. Find the x-intercept. 6.2. What's the x-intercept? Right, so we're going to find the x-intercept, which is minus x squared plus 4x plus 5 is equal to 0. Right, so we're getting x squared minus 4x minus 5 is equal to 0. We get the factors x minus 5, x plus 1 equals 0. So x is equal to 5 or x is equal to negative 1. So a is negative 1, d is 5. Okay, so now we can find the equation of this line. So the gradient is y2 minus y1 over x2 minus x1. What are the 2 points? 3, 8 that lies on the line, and the point negative 1 and 0, right? So y2 minus y1 is 0 minus 8, and x2 minus x1 minus 1 minus 3. Right, so we're getting minus 8 over minus 4, which is 2. So the gradient is 2. What's the y-intercept? Substitute one of the points. So y minus y1 is 8 equals m2 into x minus x1, which is 3. So you got 2x minus 6, and take the 8 over plus 8. So therefore y is equal to 2x plus 2, and that is g of x equals. Right, I hope you guys understood that. Simple. Find the x-intercept and find the equation of this line. Next one. Okay, I need this graph to explain the situation. Right, so explain the question there. So let me just copy that graph. Guys, if you have any comments and stuff, don't forget to comment. I hope you are enjoying the paper. It's quite simple. Besides 2 questions so far that I've experienced difficulty in. Calculate the maximum length of EH for f greater than g. Maximum length of EH, right? Maximum length of EH, right? What's the top graph? So we want to find the EH function. So I'm doing 6.3. EH is equal to top graph, which is f of x, minus the bottom graph, which is g of x. Right, and simple. Find minus b over 2a, take that value and substitute it into the EH equation, and you find the maximum length. What's f of x? Negative x squared plus 4x plus 5. Was that f of x? Negative x squared plus 4x plus 5, and we're minusing 2x and minus 2x plus 2. Right, so we have negative x squared plus 4x minus 2x is plus 2x, plus 5 minus 2 is plus 3. So we're going to say x is minus b over 2a. I'm not even using derivatives, all grade 11 work. Minus 2 over 2 times minus 1. So I'm getting 1. Minus 2 over minus 2. Take 1 and substitute into EH. So you're going to say max EH at x is equal to 1. So EH is equal to evaluated at 1. So that's minus 1 plus 2 plus 3. So maximum length of EH is 4 units. Right. So that problem is sorted out. Calculate the maximum length of EH. Maximum length of EH. EH is a function itself, right? So maximum length is 4. Substitute 1 inside here. 2 plus 3, 4 minus 1, 5. 5 minus 1, which is 4. 6.4. Solving 6.4. Given k of x, which is f of x plus m. Okay, determine the value of m such that g is a tangent to k. How can g become a tangent to k? Determine the value of m. We want a single value of m. So basically you shifted this you have to shift this graph to the left, or you shift it up. No, shifting it to the left because it says x plus m. You're shifting this curve, sorry, you're shifting this entire graph. You're shifting this entire graph to the right. So this graph basically touches this point here. So basically, how about parallel shifting it upwards? Determine the value of m such that g is a tangent to k. G is a tangent to k. Okay. In order for g to be tangent to k, k of x must be equal to g of x. K of x must be equal to g of x at a single point. So single point basically means, let me explain this. Right, so we have some graph k of x, right? And we have g of x, which is not moving. Right, so g of x is somewhere around here, is a tangent. So point of tangency, you just have single point, in other words, one solution. One solution means equal roots. So we need to find delta. We know k of x is equal to all of this function. Let me just copy this and paste it there. Right, this is k of x, and k of x is basically equal to g of x, which is 2x plus 2. Now I need to write this in standard form and then find delta, make it equal to 0, right? Equal roots implies delta needs to be equal to 0. Let's solve this. So we have negative x squared minus 2mx. Now we have 4x here already, so if we bring the 2x over, you will get 4x minus 2x, which is plus 2x, right? So I see I'm grouping all this up, minus x squared, the 4x and the 2x, I've grouped them up. Now what I am left with is constants. Minus m squared, 5 minus 2 is 3. So plus 3 minus m squared is equal to 0. I don't think I missed out anything. Let's see, minus x squared is here, minus 2mx is here, minus m squared is here, plus 4x minus 2x, so that's done, that's plus 2x, and we have 4m. What happened to the 4m? We still need the 4m here. 4m plus 5 plus 3. Right, so we have minus x squared, take out x as a common factor, minus x into, let's take out the minus x at the back, so you know what we're dealing with here. We got 2m plus 2 with the x minus 2. Okay, so we have minus open bracket, we have 2m minus 2, so minus 2mx plus 2x, right? And now we have 3 from there, 4m and minus m squared, yes, plus 3 minus m squared. Let's write this in standard form. Alright, so what we have here is minus m squared plus 4m plus 3 is equal to 0. Let me take out a negative here as well. Yeah, because I'm going to make it in standard form and multiply the whole thing by negative. Let me take out a negative here. Right, so I've got minus m squared plus 4m plus 3. Right, so we got x squared plus 2m minus 2x plus m squared minus 4m minus 3 is equal to 0. So this is my ABC. A, B, C. Now we need delta equal to 0 and then we solve for m. So delta, which is b squared minus 4ac, needs to be equal to 0. B squared is 2m minus 2 all squared. 2m minus 2 all squared minus 4. A is 1. C is m squared minus 4m minus 3 is equal to 0. Right, now we can solve this equation and solve for m. So we have 4m squared minus 4m minus 8m, double that as plus 4, minus 4m squared plus 16m, because 4 times 4 minus 4 times minus 3 plus 12 is equal to 0. Now we can cancel out the 4m squared. We have minus 8m plus 16, so we have 8m. Right, so that one so is equal to, take 4 plus minus 16, so the value of m is equal to negative 2. Right, so I hope you guys understood that, and that's what we said initially. The graph needs to be shifted to the right, so the value of m is negative 2. Nice question. Right, so I used all grade 11 knowledge here in this question, question 6. I didn't use any grade 12 derivatives and all these things, so it's purely grade 11 work that I've used here. I didn't use calculus at all. Looking at question 7, some financial maths here. Mary's grandparents deposited 5,000 into a savings account on the day that she was born. Alright, so deposit 5,000 on the day she was born. So let me just put 5,000 here. And now what's happening with the timeline? The account pays interest at a rate of 6.8% per annum, compounded quarterly. Calculate the accumulated amount in this account on Mary's 16th birthday. So 16th birthday after 16 years. Right. We want to know the accumulated amount. So A is equal to P into 1 plus I to the power n. So that's 5,000, right? 1 plus I is 6,8 over 400 to the power of 4 times 16. 4 times 16. Right, because 16 years. And compounded quarterly over 400. Right, so we got the answer. So calculator. We have to use a calculator here, financial maths. 5,000 into 1 plus 6.8 over 400, or you can say 6.8% over 4 to the power 4 times 16, which is basically to the power 64. 14,706,56. Right, that's our amount in rands. 14,706,56. 14,706,56 rands. Right, so I hope you guys are understanding. Right, let's look at 7.2. After 4 years, the value of a printer was half of its original value. Obviously, depreciation. Right, printer was half of its original value. Determine the rate determine the rate at which the value of the printer depreciated over this period if depreciation was calculated according to a straight line method. Very simple. A is equal to P into 1 according to a straight line method. What is straight line method? 1 minus IN. Right. And what was the original value of the printer? X. 1 minus I, we want the rate, and N is over 4 years. Right? I times 4. I over 100 times 4. Okay, we can multiply by 100 at the end, so let's just keep it. I times 4 is equal to half x. We don't have to use x and half, you can just use 1 and half, right? The value 1 and half. You can even use 1500, whatever. So we got 1 minus 4i is equal to 0.5. Okay, minus 4i is equal to negative 0.5. 0.5 minus 1. So I is equal to half divided by 4. So basically you're going to get 1 over 8. You can try it out. 0.5 divided by 4. Right, you're getting 1 over 8, which is 0,125. Therefore, I is equal to 12.5% per annum. Right, so that's your depreciation rate. Right, so that's your, according to the straight line method. Let's look at 7.3. SEPA was granted a loan of 100,000 on 1st March 2022 at an interest rate of 13.5% per annum compounded monthly. SEPA agreed to repay the loan over 5 years in monthly installments of 2,300.98 starting 1st April 2020, March, April, so straight away. So he was granted a loan at 0, which corresponds to this timeline here. Granted a loan of 100k at 0, and he started paying at this point x. We have the value 1, we have the value there 2, and so on for 5 years, which is 5 years, which is 60 months, right? 5 times 12. The loan is monthly and he's paying monthly installments, right? Calculate the total interest that he will pay over the 5 years. Total amount of interest over the 5 years. So we need to work out the total interest over 5 years. Accumulate the loan amount for 5 years and minus the total amount. So it's basically total amount paid minus the loan amount. Calculate the total interest that he will pay over the 5 years. So total interest is equal to total interest, total paid. Yeah, so you're gonna have 2,300.98 times 60 minus the original loan amount 100,000. 2,300.98 times 60 minus 100,000. So the amount of loan that the amount of interest you paid is 38,058.8. 38,000 0.80, 38,058 rands and 80 cents. Should we accumulate this? No, I don't think it's, you're not supposed to accumulate the 100,000. Then you'll get, it's the total amount that you paid minus the original loan amount will give you the total interest. Yes, if you try to do this, it will not work out. 13.5 over 1200 to the power 60. No. Yeah, so this should be fine. That's the total amount of interest that you paid. Right, so Sepo paid 22,300.98 his monthly installment and an additional 20,000 on 1st March. Sepo paid 22,300.98 his monthly installments and an additional 20,000 on 1st March 2024. How did he pay 22,300.98? I think 22,300.98 on 1st March. He started on 1st March 2022 and now 2024. Sepo paid 22,300.98 his monthly installment and an additional 20,000 on 1st March 2024 into the loan account. One second. So this is 2022, 2024. He started payment on the 1st of March 2022. So that's already 24 months into his payment. 2,300.98 times 24 55,223.52. Sepo paid 22,300.98 his monthly installment. What was his monthly installment? His monthly installment was 2,300.98. Okay, let's try to make sense of this problem here. Alright, so we have 60 months in total. So obviously they're going to drop his if he's paying 20,000 additional on 1st March. So remember this was the 1st of March 2022. That's when he took out the loan, and 2 years later so at 24th month still paying X. 2 years later he's depositing a further 20,000. He paid an additional 20,000 on 1st March 2024 into the loan account, which is at the 24th month. He continues to pay the original monthly installment thereafter. How many months earlier will Sepo repay the loan? So at 25 he's still paying X. How many months earlier will he repay? So what we're doing is we're dropping the loan by 1st March 2022. So we're just checking if this is 24 is correct. Should it be 24 or 23? First March, yes, it should be 24, right? So he paid for 24 months. So outstanding balance after 24 months, outstanding balance after time is equal to 24 months, right? What's the outstanding balance on the loan after 24 months? So x into 1 minus 1 plus I to the power negative n divided by I. So what we have is x 2300.98 2300.98 into 1 minus 1 plus what's I? I is basically 13.5 over 1200 to the power negative 36 all over the interest, which is 13.5 over 1200. Right, so we're getting 2300.98 into 1 minus 1 plus 13.5 over 1200 to the power negative 36 over 13.5 over 1200, or you can say 13.5% over 12. Right, so I'm getting 67,804 point 67,804.9364294. Right, now because you paid an additional 20,000, it's going to drop the outstanding balance on your loan. Right, so now what we have is payment of 20,000 rands. Okay, so you got 94, drop this, now you have 47,804. That's a loan amount that you have now left because you paid an additional 20,000. Now we need to calculate for n. Still have to pay off for 36 months left. So we have 47,804.94 is equal to x, which is 2,300.98 into 1 minus 1 plus 13.5 over 1200 to the power negative n over 13.5 over 1200. We're going to multiply these two divided by this. And multiply by 13.5 over 1200, and then divide by all of this, divide by 2300. Actually, you could have just divided here, don't have to take the whole thing and divide and multiply across. Right, and that's equal to 1 minus 1 plus 13.5 over 1200 to the power negative n. So we're going to take this onto the other side, right, and use logs. So obviously if you take this to the other side, it's going to become positive, right, and 1 minus, I'm just copying and pasting here, right, so, and then this one here you're gonna minus, and then you have to apply logs. So I'm just going to enter the whole thing one time into the okay, let's get some decimal values here, full decimals please. Right, so 1 plus 13.5 over 1200, I'm getting 809 over 800, and that whole thing is to the power negative n, and this, all of this minus 1 minus 47,804.94 over 2,300.98 multiplied on top by 13.5 multiply at the bottom by 1200. Right, so I'm getting an answer of 0.766 0.766271 0.766271 078. Right, so n is equal to, remember it's negative n, so I'm going to put negative log 0.766271 base 809 over 800, or 1 plus 13.5 over 1200. Alright, so let's see what answer we get. I'm just going to say I'm just going to say, what was my answer? Right, that's my answer. So log answer here, negative in the front, base 809 over 800. So I'm getting 23.76 23.80 23, I'll write the whole thing, 796 79782. Right, so approximately 24 months. What did they say? 24 months, or how many payments left? How many months earlier will SEPO repay the loan? So 12 months earlier, 24 months left to pay. 12 months earlier. Right, so SEPO will repay the loan 12 months earlier, because remember in total we had 36 12 months earlier, just because he made a payment, a lump sum payment of 20,000 towards his loan. We have a problem because, see, there's 22,300. Why is this information there? It's irrelevant. SEPO paid 22,300.98, his monthly installment. His monthly installment was not 22,300.98. His monthly installment was 2,300.98. I think there's an error here. There is an error here. Okay, I think there is an error here. Shouldn't be 22,300.98. Oh, because his monthly installment is not 22,000, it's 2,300.98, 7.3.2. Yeah guys, I think there's an error in this question, but anyways, this is the way to solve it. I hope you guys understood what I've done here. Right, let's look at question 8, which is calculus, and we're almost done. Right, I'll try to finish as quickly as possible. So we want to find the derivative of this. It's already written here in power form. So d dx, derivative of 3x is 3, and derivative of minus 5x squared is minus 10x. Done. Write this in power form. 2x to the power negative 2, inside over outside, minus x to the power 7 over 3. Now differentiate. This is just g of x. So g prime x is minus 2 times 2 is minus 4, x to the power negative 3, minus 7 over 3 times minus 1 is minus 7 over 3, x to the power, take away 1 from here, so minus 3 over 3 will give me 4 over 3. 7 over 3 minus 1 is 4 over 3. 7 thirds minus minus 1, 7 thirds minus 1, so 7 minus 3 is 4. Yeah. If you want to rewrite it, that's minus 4 over x cubed minus 7 over 3, write it in square root form, x to the power 3 outside, 4. Right. Don't have to write it in this form, but it's advisable. So I hope you guys understood that. Continue. Determine the equation of the tangent 2. To find the equation of the tangent, we need a point of contact first. So point of contact is 2 and f of 2. So let's find f of 2. F of 2 is equal to putting 2 inside here, so that's 8 minus 4 times 4, which is minus 16. 2 times 2, which is 4. 4 plus 3 is 7. So plus 7. I'm getting minus 1. Right, so point of contact is 2 and minus 1. So what's the gradient? So f prime x will give me the gradient function. What's f prime x? The gradient function. So 3x squared minus 8x plus 2. If you substitute 2, you will get the gradient. Remember, we're trying to find y is equal to mx plus c. If you substitute 2 inside, you will get the gradient, or use this formula, y minus y1 equals m into x minus x1, and then transform here. We already have a point of contact to the tangent line and the cubic function. Remember, the cubic function is something like this, right? And we're trying to find the point of at x is equal to 2. Maybe 2 is there or there, we don't know. So 2 and minus 1, I'm thinking is here somewhere, right? 2 and minus 1. So I'm trying to find the equation of this tangent line. So f prime x, 3x squared minus 8x plus 2. I differentiated this, substitute 2 inside, I get the gradient, because f prime x represents the gradient function. So I'm putting 2 inside here, that's 12, because 2 squared is 4, 4 times 3 is 12, minus 8 times 2 is 16, plus 2. So that's minus 4 plus 2, which is minus 2. Right, so we've got a gradient, y minus y1. What's y1? Minus 1. Y minus minus 1 is y plus 1. Gradient is minus 2, x minus 2. Let's find the equation of this tangent line. Okay, maybe it wasn't that one. The tangent line is showing is negative gradient. So let's solve 12 minus 16. Just double check, right, minus 2. So we got y is equal to minus 2x plus 4 minus 1. So minus 2x plus 3. So what's the equation of the tangent 2? Thus at x is equal to 2 minus 2x plus 3. That's the equation of the tangent. Let's move on to the next problem. We are looking at first principles, right? Simple. Copy the formula from the formula sheet. F prime x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Limit as h approaches 0. Instead of writing all over h, I'll just take out the 1 over h and call it f of x plus h. That's minus 6 into x plus h all squared minus 6x squared. Right. Now let's simplify and solve. Minus 6 into x squared plus 2xh plus h squared plus 6x squared. Limit as h approaches 0 of 1 over h minus 6x squared minus 12xh minus 6x h squared plus 6x squared. Now what we can see is that these two terms cancel out, right? So we can take out h as a common factor as well, so that also cancels out, right? So what we have is limit 1 over h into, take out h as a common factor, we're left with minus 12x minus 6h. Right, now we can see the h and the h cancels out. Substituting h as 0 into minus 12x minus 6h. The answer is this, minus 12x. Right, I hope you understood that. Don't forget to leave comments if you don't understand anything. So minus 12x. Perfect. Write down how you will restrict the domain of f such that f inverse is a function. Alright, so lovely, nice question. So what's the function here? Minus 6x squared. You know, that's the upside down parabola, right? Now that's upside down parabola minus 6x squared. I'm not putting any points here, right? So minus 6x squared. Let's look at this one piece of the parabola here for an example. We have to restrict the domain. We have to make the function 1 to 1. So it has to be on the positive x side. So we know the domain, restrict the domain of f such that f inverse, the inverse of f is a function. How will you restrict the domain? So you say x is greater than equal to 0, right? Or you can say x is less than equal to 0. You can either choose the left side or the right side of the graph. So the domain, you can restrict the domain like this, either this or this. Write down how you will restrict the domain of f such that f inverse is a function, right? So we kind of restricted the domain. You choose one of them. Actually both. It's either this or that. Determine the equation of f inverse which is less than equal to 0. Write your answers in the form y equals. Alright, so I'm going to find the equation of f inverse here. Alright, let's see. F is a function y equals negative 6x squared. So f inverse is a function x equals negative 6 y squared. So we're going to take this y squared is equal to negative 6. No, y squared is equal to x over negative 6. Right? So y is equal to plus minus the square root of x over negative 6. And we want the f inverse function which is negative. So this implies f inverse x which is equal to y, right, which is negative square root of x over negative 6, or negative x, let's write it as negative 1 over 6x. Right. So obviously x has to be negative and y is negative. X is negative, y is negative. So you're basically looking at an inverse. They are looking at the inverse function, remember, which is like this. Right, so this is the bird and this is, right, so they are looking at this inverse function here, where because x has to be negative and y has to be negative, so this inverse function actually goes in the third quadrant. Write your answers in the form y equals. Remember, x has to be less than equal to 0 and y is also less than equal to 0. So these are the domain and range. They didn't ask for domain and range. Okay, we can give it. Always write extra than to write less. Alright guys, so far everything is good. Let's look at the next question. Calculus question. A, which is 1 and 9, and B, which is 5 over 2 and 8, are the turning points of the graph of f. Below C is 0, 7 is the y-intercept of f. For which values of x is f decreasing? Decreasing is, we need a graph. What does decreasing mean? Decreasing basically means looking for a downward slope. So when is the slope downwards? Only here. So you can see the turning points here. There's one turning point and there's another turning point. That's where it's happening. The decrease are A and B turning points. A and B are the turning points. So it's decreasing here from 1 to 5 over 2. 1 to 5 over 2. from 1 to 5 over 2, decreasing. Right, decreasing. Perfect. Move on to the next question. Write down the x-intercepts of f prime. What are the x-intercepts of f prime? It will be the turning points of f derivative graph, right? So x is equal to 1 or x is equal to 5 over 2. That's it. For what values of x will f be concave up? Concave up, remember, values of x is going to be an inflection point which is between the turning points. And how you get this inflection point? Inflection point, x value of inflection point is equal to, add the two x values, divide by 2. So 1 plus 2.5 divided by 2, which is 3.5 divided by 2. Right, so what is 3.5 divided by 2? 3.5 divided by 2. We want the midpoint, which is 1,75, 7 over 4. Right, which is around, yeah, 1,75. Right, because this is 2.5, right, and this is 1. So add 7.5, yes. So it will be concave up when? Concave up is like a happy face, right? Concave up is from here, that inflection point. So x is greater than 7 over 4, not 7 over 2. Concave up after 1.75, or x is greater than 7 over 4. Determine the value of k for which f of x plus k will have 3 positive x-intercepts. When will you have positive x-intercepts? At the moment, it has one real root, right? Y is equal to f of x plus k. At the moment, what I'm doing is I'm solving for f of x is equal to k. For three positive roots. When will you get 3 positive roots? If the value of k, you have to cut above. If you cut between the y-intercept and 8, nothing's happening here, right? This line is 8, so you have to cut between 8. You have to cut the graph between 8 and here to get 3 positive. Yeah, it has to be between 8 and 9. You have to cut the graph between 8 and 9. One, two, three. F of x is equal to k. You have to cut the graph between 8 and 9. So so for 3 positive roots or 3 positive x-intercepts, positive means x is greater than 0, right? So that's what we're looking for. So the value of k has to be between 8 and 9. 3 positive x-intercepts should be distinct. For distinct, they didn't say 3 different, they just said 3 positive x-intercepts. Okay, for distinct, that's what I'm using. The value of k should be between 8 and 9. But now they have put y is equal to f of x plus k. You have to shift this graph 7 units down though. You have to shift this graph. You have to shift this graph in such a way that it has positive roots. So I'm looking at 8. If I shift this graph 8 units down, if I shift this graph 8 units down, then it will cut here 8 or 9 units down, then it will have 3 x-intercepts. So it should be negative here because we brought that over. Yeah, so 8 negative k is a 9, should be negative 9 to negative 8. So I'm looking at negative 9 because you have to shift this graph. Somehow you have to shift this graph, the value, you have to shift this graph 8 units down, 8 or 9 units down, between 8 and 9 units down to get this, because usually we solve for things like this, but that's not the case. Determine the value of k for which y equals f of x plus k will have 3 positive x-intercepts. Yeah, I think this is the value of k. At the moment we have only one negative root. If you shift this 8 units down, if I shift this whole graph 8 units down, should get positive roots. 0 less than 7. Okay, if I shift this entire graph, let's see. For understanding purposes, I'm just drawing this, tracing this figure out. So obviously you can't shift it higher up, but what you can do is shift this graph. This is shifting is 7 units down, alright? If I shift this graph 7 units down, then I'm stuck at 2 here and 1 here. So I need to shift it a further 1 unit down. So basically I went right down till 8. So k has to be greater than negative 8. I have to shift it more than negative 8, and yes, more than negative 8 and more than negative 9. No, but less than negative 9. Yeah, so I think we'll go with this answer. I hope you guys are understanding. Because at the moment we have 1, yeah, less than, yeah, this should be fine. Right, let's look at the next question. Hope you guys are understanding all this. Now the next question, as we see here, question number 10. A cyclist rode from town P and stopped at town S. Rode from town P and stopped at town S. Town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by the equation S prime T. Right, so we already have the is represented, the speed at which the cyclist rode is represented by the equation. There's already the speed function. Minus 3t squared plus 18t. Calculate the maximum speed that the cyclist reached on his on this ride. 10.1. Maximum speed will be minus b over 2a, or you can just find s double prime t, because that's s prime t already. You find another derivative. We know s prime t is represented by v of t. Let's just write v of t. So minus 3t squared plus 18t. So we're basically finding s double prime t, which is v prime t, right? And we're getting minus 6t plus 18 is equal to 0. So t is equal to 3. Now if we substitute t is equal to 3 inside here, then we will get the maximum, right? So s prime 3, so we're saying max speed is s prime 3, which is minus 27 plus 18 times 3 is 54. We can try substituting 3 inside here, right? So minus 27 minus 27 plus 54. I'm getting 27 kilometers per hour. That's the maximum speed. Calculate the distance between town P and town T. Town P and town T. I want to draw a graph to represent this, alright? So you can understand this better. Right, let's see. So we know the equation is minus 3t squared plus 18t, but that is the speed function. Calculate the distance between town P and town T. What function is this? The speed in kilometers per hour at which the cyclist rode is represented by the equation s prime t, which is minus 3t squared plus 18t. Calculate the distance between town P and town T. Okay, so how are we going to calculate the distance? Let's see. We know that this function is starting from 0, is sad phase, right? It's going from 0 to 3. 0 to 3, how? No, it's from 0 to 3, sorry. S prime t. Let's look at the s prime t function. Is minus 3t squared plus 18t. When you take out minus 3t as a common factor, we have to t minus 6. T minus 6, yes, so 6, 0 and 6. And the maximum speed is here at 3. So you started here P and stopped at T. From P to T. Calculate the distance between town P and town T. Maximum speed was at 3, which was, what was the maximum speed? It was at 3, which is 3 and how can we calculate the distance between town P and town T? The distance from 0 to 6 is basically the velocity, is basically the time points. Calculate the distance between town P and town T. We can work backwards and see if we can solve this. So if we try to recover s of t function and work backwards, we know we got a times ax cubed plus bx squared. No, but we got minus 3. So we can try to recover the distance function and substitute 0 and 6 and get the distance. It's basically finding the, obviously if you use advanced maths you can find the area under this curve and get the distance between 0 and 6 to find the to find the total. So obviously I do know the answer using advanced maths, but for you guys, let's see. You can just find integral from 0 to 6 of the function minus 3t squared minus 3 alpha x. I just want to see what's our answer. Plus 18 plus 18 alpha x. So it's 108. The distance is 108. Yeah, so that's the answer we need. Right, so let's see. S of t, we know, I'm trying to recover the original function, the cubic function. Remember, the cubic function is something like this. That's my cubic function. The turning points are exactly from here. The turning points is occurring at 0, and the next turning point is occurring at 6. 0 and 6 are the turning points. I'm trying to recover this function here. Right, I have a turning point at 0, I have a turning point there, and that's a point of inflection, which is 3. So S of t is negative t cubed 18t it should have been 9t squared. So 2 times 9 is 18 plus a constant, because there's nothing else, plus some constant c, c plus constant c. Yes. So if this person started at if t is equal to 0, if t is equal to 0, if t is equal to 0, then the velocity is the speed is also equal to 0. Speed is equal to 0. Then this person started at 0, so s will also be equal to 0. So we're going to solve this equal to 0. So s of 0 just gets 0 at p, because you're starting at p. There is no distance at p. This is a starting point, that's your ending point, traveling in that direction. S of 0, so you're going to get negative 0 plus 0 plus c equals 0. C is equal to 0 because I substituted all here. Right, so let's just show it. Times 0 squared plus c equals 0. So we're just getting c is also equal to 0. So this is my function. Right, now I can just find s of 6 after, obviously after 6 minutes it stops. Right, so at t, substitute 6 inside, you say negative 6 cubed plus 9 times 6 squared. Right, so let's see. Negative 6 to the power, put your calculator on, negative 6 to the power 3 plus 9 times 6 squared. I'm getting 108. Perfect. 108 kilometers. The distance between the two towns is 108 kilometers. Remember, the advanced method is to find this or if you know integral calculus, pt, the distance pt is integral 0 to 6 of the function, which is the speed function minus 3t squared plus 18t. In the calculator, just change the t into x and you get 108 kilometers. Right, so that's my answer, the distance between the towns pt. So let's write distance between towns. Town is 108 kilometers. Right, let's continue with the next question. A certain number of learners are sitting for examination in mathematics, tourism, and geography. So we have mathematics, tourism, and geography. All these learners sit for at least one of these examinations. The total number of learners who sit for mathematics is 22. Right, so we need to draw a Venn diagram, okay? All these learners sit for at least one of these examinations. The total number of learners who sit for mathematics is 22. Total number of learners sitting for tourism is 6. The total number of learners, 5 learners sit for mathematics and tourism but not geography. 4 learners. 6 learners sit only for tourism. Right, we're going to draw a three-way Venn diagram. And make sense of the problem. All these learners sit for at least one, so they either sit for 1 or 2 or 3. The total number of learners who sit for mathematics is 22, so we're not going to start filling that. We start filling from the bottom. 6 learners sit only for tourism, so mathematics, tourism, what did we have in order? Let's go in order. Mathematics, tourism, and geography. We'll put geography at the bottom. 6 learners sit only for tourism. Only for tourism means 6 here. Tourism only. Remove the rest. Right, so that's done. So you always start filling in 3s and 2s and then 1s. 3 learners sit for tourism and geography. Tourism and geography, but not mathematics. Tourism and geography is 3, but not mathematics. That's 3. So that's done. 4 learners sit for mathematics and geography, but not tourism. Mathematics and geography, but not tourism. 4. 5 learners sit for mathematics and tourism, but not geography. 5. The total number of learners sitting for geography is 18. I think this is going to be X. The total number of learners sitting for geography is 18. So total number of learners sitting for geography, the entire circle of geography is 18. So 18 minus 7, and then we need to minus the X for geography. 11 minus X. So we put 11 minus X. So if you total all, you will get 18. The total number of learners sitting for geography is 18, right? The total number of learners sitting for tourism is 16. Very important information. For tourism is 16. Now we can solve for X. For tourism is 16. But tourism is already 11 plus 3, which is 14, plus X, which is equal to 16. So X is equal to 2. So you can put 2 here now. Right? If that is 2, then this will become 9. Next one. The total number of learners who sit for mathematics is 22. Mathematics circle is 22, so 5, that's 11 here then, total. So 5, that's 20, 22. Right, so that's my diagram completed. Next question. Calculate the probability that a learner chosen at random will sit for examination in at least 2 of the subjects. At least 2 of the subjects means 2 or 3. At least 2 of the subjects. So we need to add the total of 5, 3, 2 and 4. Because that's at least 2, at least 2, at least 2, and this is all 3. Alright, so probability is 5 plus 4 plus 3 plus 2 divided by, what's the total? What's the total here? So if I sum up all this, what's the total? Total was 22 in this circle. Mathematics was 22 plus this whole thing summed up. 6 and 3 is 9 plus 9. So we're getting 40. Did they say 40 learners? Certain number of learners, so this is over 40. So that's going to be 9 and 5. 14 out of 40, that is 14 divided by 40. That answer is 7 out of 20. Right, so I hope you guys understood that. Right, it went right to the top. Go back. Right, determine if the events sitting for examination in mathematics and sitting for examination in tourism are independent. So probability of mathematics and tourism is equal to, what's mathematics and tourism? Mathematics and tourism is 7 out of 40, comma, and what's the probability of mathematics times the probability of tourism? That's 22 out of 40 times tourism is 6. What was tourism total? 16. Yeah, 16 out of 40. So we need to check this. That's 22 over 40 times 16 out of 40. And we're getting 11 out of 50, right? So therefore, probability of mathematics and tourism is equal to determine if the events sitting for mathematics in mathematics and sitting for examination in tourism are independent. Is clearly not equal to so this is the calculation I showed. Probability of mathematics is 22 out of 40. Probability of tourism is 16 out of 40. So you can say not independent. Right, so they are not independent because we're getting the different values, 7 out of 40 and 11 out of 50. They're not the same. Right, let's look at the last question, question 12, right, and finish off. A company generates a 4-character code using 26 letters of the alphabets and 10 digits from 0 to 9. So it's a 4-digit code. Letter, digit, letter, digit. Alright, so determine how many different codes can be formed if letters and digits may be repeated. So letter, 26, digits, 10, letter, 26, digits, 10. So that's the amount of codes that can be generated. So you can say 26 squared times 100, so 67,600, right? 67,600. Look at 12.2. Determine how many different codes can be formed if the letters D, F, I, Q, U and V may not be used, right? So 6 out, right? The code may not start with W or Z. Letters or digits may not be repeated. The code ends with an odd digit. Ends, right? So we need to look at how many odd numbers here, and it may not be repeated as well. The code ends with an odd digit. If the code ends with 1, okay, let me look at the letters first. 1, 2, 3, 4. Ends with 1. So it can end with 1, 3, 1, 3, 5. So it ends with 1, 3. Let's just say if it ends with 1, 1, 3, 5, 7, or 9. If it ends with a 1, then I can't use a 1 here. So I've got 9 options there. Out of 10, I've got 9 options there. Right? I've only got 9 options there. And the letters may not start with W or Z. So we got another 2 out from the beginning. So 26 minus 6, that's 20. We got 18 options here. 9 options there. And how many options do I have here? Just say if I use one of the letters like A, I use the letter A, so I've got, remember I've got 20 options in total. So I can use 19 here now, because I can use W and Z over here. But now the letters ends with, but it can end with, now the same option can be repeated 5 times because of 1, 2, 3, 4, 5, right? So it can end with these things here. So I will say times 5 at the end. Okay, so I've got 18 times 9 times 19 times 5, right? Why do we have 18 here? Because we have 18 options here. If I use up one of the letters A, so I've got 20 minus one option. I've got 19 option here. Yeah, because I can use it. It can't start with W or Z, but it can end with these. Okay, so that's what I have. I've got 15,390. Now, what's the last question here? The company wishes to increase the number of character codes. Yeah, I think this was just got cut off there. Let's see. Increase the number of 4 character codes. Increase the number of 4 character codes. The company wishes to increase the number of 4-character codes formed in question 12.2 by allowing the letters D, F, I, Q, U, and V to be used. Calculate the percentage increase in the number of different codes that can now be formed. So same problem, right? So we can use, so just minus 2 there then. So new, you're gonna minus 2. So we're gonna have 24 because we can't use 24, 9, 19, not 19, 25, because I can use all to say if I started with A here, then yeah, because I can't start with W or Z, but I can use these ones now. I can use those 6, W or Z. So put 24 options here, but I can use W and Z there, so I just minus one of them. Alright, so we got 26, 25, and then 5 at the end. Calculate the percentage increase. Alright, so let's see. Change this into 24 and that into 25. Right, so we got 27,000. Right, so the percentage increase will be uh, 27,000 minus, yeah, what will the percentage increase be? How do you calculate the percentage increase? Remember, 15,390 is becoming, there's a percentage increase here, is becoming 27,000. So 27,000 divided by 15,390 minus 1 times 100. Right, so that's how I'm going to work it out, times 100. Right, so 27,000 divided by 15,390 minus 1 times 100. So I'm looking at 75,430 0.754 0.75439 44 75,44%. That's what I'm looking at. That's the increase. I hope you guys understood this and enjoyed my video. If you have any comments, don't forget to leave comments below. Thank you so much.